From our previous video, we have our two green triangles. They're green because in the fragment shader, we said for every fragment, please color it green. So thus they all turn green. But that's an issue because we said that every single vertex was going to be red. And if you would think the corners of each triangle are red, the entire triangle would be red. And I even went as far in the last video to call these pass-through shaders, but they're not really pass-through shaders. Yes, we pass the positional data on through to the hardware, but the only thing the hardware uses that positional data for is to know where the vertices are located. It's not like the hardware actually renders these vertices. It just says, oh, I have a triangle from these infinitesimally small, did I say that right? Infinitesimally small vertices, and these are the fragments that the triangle covers, so let's color them all in green. We didn't actually pass through the vertex color. So in this video, I want to pass the vertex color on through. Let me bring the diagram back up here. We sent our attributes into the vertex shader. The vertex shader didn't really do much, but it output the position. It passed the position on through to the hardware, so the hardware can decide where the triangle is. But we didn't send any other data out. Right? The other data that we need to send out is data R. I love it when people say the data R, and I think that's right, but holy smokes, the data that we want to R out is the color information. The fragment shader has no idea about the color. We simply went and said, hey, hard code green in there. Remember, this is red, green, blue. I want to actually use the vertex colors instead, so let's do that. Recall from the previous video, we sent the positional data as an input to our vertex shader. It is the zeroth attribute we described as the zeroth attribute being two floats right there. Now we need to take our three floats for the color information. We already described to OpenGL that attribute 1 is made up of three floats, but nowhere in our vertex shader code did we make a spot that we can accept those three floats. So let's do exactly that. The syntax is identical for this, except with a little bit of a twist. We say in layout for attribute 1, that's what location means. Location equals 1, attribute 1. We want, or will accept, we are expecting three floats. Okay, and we'll call it vertex color, because that's the color of the vertex. Now, if you're compiling this shader code and you get compile errors saying, hey, layout's not supported, you can actually specify this information using OpenGL. I can't remember the exact functions you call. It's like one or two functions that you have to call before linking your program. So have no fear, it's out there. My graphics card is pretty up to date, so it'll allow for this syntax inside of my shader code. Okay, vector 3 vertex color. In order to send our data out of this vertex shader, we're going to need a out parameter. So Control L, Control VV, out vec3 the color. And then down here in main, I'll simply say the color gets vertex color, like so. Now bringing the diagram back up here, we are sending the color in. Vertex shader doesn't do anything fancy, but send it out. The graphics hardware takes that data, and every time the fragment shader runs, it sends that data into the fragment shader. So what comes out of the vertex shader must come in to the fragment shader. So let me specify here an input variable, vec3, the color. How does OpenGL know that the color maps to this color? Well, it's by the names. The names have to be identical. If this is not named the same as that, then I'll get bogus information here. Probably all zeros, but it won't link up. It won't send the information down from the vertex shader to the fragment shader. Now that I have the color in here, it's real simple. I'm going to take these three floats that we hard-coded and replace it with the color. So we construct a vec4. We say take the first three floats from the color. It's three floats. And then the last one is completely opaque. And that's it. That's it. That's the whole pipeline. Each one of these attributes sent through the vertex shader. We send out the color through here, through the color, goes out of the vertex shader, sent into the fragment shader, into the fragment shader. We use it to send it back on out to the fragment shader, making the color of that fragment. We sent it out of the fragment shader to make the RGB values. And if we did this right, when I run this, we shall see two red triangles. Let's try this. I have to close the one I already had open. Right there. And Control F5. Drum roll. There are our two red triangles. Very cool. So that now hopefully you're starting to see the graphics pipeline. We're sending our data through this pipeline I drew up here. And we're going to revisit this several times over so we can fully understand what's going on. But there you go. Now we have a true set of pass-through shaders, and we're rendering our triangles.